Welcome back, Cyclone Scientists. Today we're going to be talking about the atom. Atoms make up all matter in the universe. They're the basic unit of matter. And today we're going to talk about what makes up an atom. So it turns out that atoms are made up of three subatomic particles or parts. The first part of an atom is a proton. Protons are positively charged and are located in the center of the atom, what we call the atom's nucleus. The second subatomic particle are neutrons. Neutrons have no charge. They're neutral. We sometimes put a 0 to indicate that they're neither positive or negative. And they're also located in the atom's nucleus with the protons. The third and final subatomic particle is an atom's electrons. Electrons are negatively charged and are orbiting around the protons and neutrons in what are sometimes called energy shells or orbitals. Now, one thing to notice is that the protons and neutrons are much larger than electrons. Pretty much all of an atom's mass comes from its nucleus, from its protons and neutrons. Electrons are so small that we really don't even have to consider them when we're calculating the atomic mass. And that'll be important later on. So we can actually get a lot of information about these subatomic particles by looking at an atom's tile on the periodic table. For example, here's one tile off the periodic table for the element carbon, which is abbreviated with the symbol C. Now on each tile of the periodic table, there are two numbers. This first number, the one on top, and usually the smaller of the two numbers, is an element's atomic number. This is always the number of an element's positively charged protons. This is actually how we identify an element. I'm going to say that again because it's so important. The way we identify an element is by its atomic number or the number of protons. And that's because this is really what defines an atom as that element. The reason this is carbon is because it has 6 protons. If it had any number other than 6, it would no longer be carbon. Now, typically in a normal atom, the protons are also equal to the electrons. And so the atomic number will give you the number of protons, the positive, as well as those negatively charged electrons that are orbiting around the nucleus. Now, the second number and the larger of the two, usually located on the bottom, is what's called the atomic mass. Now, remember what I said before. The atomic mass really only includes 2 of the 3 subatomic particles, the 2 larger ones, the protons and the neutrons. And so you'll notice that with just a little bit of math, we can get the number of all 3 subatomic particles just from this one tile. The atomic number tells us the protons and electrons, and if the atomic mass is the protons plus the neutrons, if we want the number of neutrons, we simply take the atomic mass, which is 12, and we subtract the atomic number, which is 6, giving us a total of 6 neutrons. So just from one little tile, we can get a lot of information. Now, the only exception to what I just told you is if the element is what's called an ion or an isotope. An ion is an atom with an overall charge. This happens because when atoms bond with one another, they often gain extra electrons or lose electrons. Remember, the protons can never, ever, 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 ever change. But for example, in this bond that we see here happening between sodium and chloride, the sodium is giving up or losing an electron to chloride. So it's going to become positively charged. So I looked at the periodic table, I might see something like this, Na plus 1. This indicates to me that now when I'm calculating my numbers of protons, electrons, and neutrons, I need to keep in mind that the sodium has lost 1 electron and is therefore positively charged because its protons now outnumber its electrons. The opposite is true over here for my chlorine. My chlorine is gaining 1 electron from sodium, and so when I write this out, I might write something like this, Cl minus 1. And I need to know that when I'm calculating my protons, electrons, and neutrons, that I need to add an extra electron, which may seem kind of funny since this says minus 1. But remember, electrons are negative, so if you get more of them, you become more negative. So when chlorine has 1 extra electron, 1 more electron than it has protons, it becomes minus 1. The other weird situation you might come across is something called an isotope. An isotope is an atom that has a different number of neutrons. Remember, those protons can never, ever, 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 ever change, but it is possible for an atom to have a different number of neutrons. So for example, these are two isotopes of oxygen. The first is the normal oxygen isotope, the one we see in the periodic table with an atomic mass of 16. This oxygen has 8 protons and 8 neutrons for a total of 16. But this is oxygen with an atomic mass of 18. So it has 2 extra neutrons. It has 8 protons and 10 neutrons. You might remember from our geology unit that some isotopes are actually radioactive and can help us to date really, really old rocks and fossils. So that's it on the atom and the subatomic particles. Good luck studying for your test. Thanks, guys.